Have you ever gazed up at the night sky and noticed a tiny, glowing red dot among the stars? That's Mars, our mysterious planetary neighbor, quietly orbiting the sun alongside Earth. For centuries, it has captured our imagination, inspiring stories of alien life in distant worlds. Today, Mars is a cold, dry, and dusty world, its surface battered by relentless winds and blanketed in rust-colored soil. It's a place that seems utterly hostile to life as we know it, with freezing temperatures and almost no water. But what if we could turn back the clock by 1 billion years? Would Mars look familiar, maybe even a little like Earth? Imagine a time when the red planet was not so different from our own blue world. Picture yourself stepping out of a time machine onto ancient Mars. The landscape before you is both alien and strangely inviting, a world in transition. The ground beneath your feet is made of volcanic rock and rich, dark soil, not the endless desert we see today, but a surface shaped by powerful forces. A gentle, moist breeze brushes your face, carrying the faint scent of minerals and perhaps even the promise of life. The air feels different, alive with possibility. The atmosphere is thin, but much thicker than it is today. You can almost feel the weight of it, enough to support clouds and weather. The sun hangs low in the sky, smaller and dimmer than on Earth, but its rays still manage to warm the Martian surface, casting long, dramatic shadows. Overhead, the sky might be a pale blue or a hazy orange, with real water clouds drifting lazily across the horizon, hinting at a climate that once supported rivers and lakes. This ancient Mars has weather, seasons, and a dynamic landscape that changes with time, much like Earth's own ever-shifting environments. By studying Mars's rocks, canyons, and ancient riverbeds today, scientists act as detectives, piecing together clues to reveal the story of this lost world. Each new discovery brings us closer to understanding a planet that may have once been a true sibling to Earth, raising the tantalizing question: could life have ever thrived on ancient Mars? Let's journey back in time, far beyond the reach of human memory or even the earliest life on Earth. Imagine exploring the landscape of ancient Mars, a world that was both wild and mysterious. 1 billion years ago, Mars was a planet of extremes. Towering volcanoes like Olympus Mons erupted with unimaginable force, spewing lava and ash high into the thin Martian sky, shaping the land for millennia to come. Vast lava plains stretched for hundreds of miles, their surfaces still warm from recent eruptions, while gigantic canyons like Valles Marineris cut deep into the crust, forming scars that would last for ages. Water, perhaps in the form of rushing rivers or seasonal floods, may have surged through these chasms, carving valleys and gorges, leaving behind evidence of a wetter, more dynamic Mars. The surface was a tapestry of dark volcanic rock, lighter sedimentary layers, and rusty red soil, each telling a story of ancient eruptions, shifting winds, and flowing water. Craters dotted the landscape, but many of them held shimmering lakes instead of dust, bodies of water that reflected the pale sunlight and the pinkish Martian sky. Imagine standing on a crater rim, gazing down at a circular lake, its surface rippling gently in the breeze, mirroring the clouds drifting overhead. These lakes were true oases in a harsh environment, protected pockets where water pooled, and perhaps even life could have found a foothold. The landscape was a dramatic mix of fire and water, creation and erosion, with volcanoes building new land and water wearing it away, constantly reshaping the face of Mars. Unlike today's cold, dusty Mars, this ancient world was alive with geological activity. Volcanoes erupted, valleys deepened, and lakes formed and vanished over eons. The colors and textures were richer, more complex, a landscape painted in shades of red, brown, and ochre, with layers revealing the planet's tumultuous history, a truly alien yet strangely familiar world. Ancient Mars was a planet in motion, shaped by powerful forces of nature, a world that invites us to imagine what might have been, and what secrets still lie hidden beneath its surface. Could you breathe on ancient Mars? Not quite. The atmosphere was thicker than today's, but still lacked enough oxygen for humans. Air pressure was higher, like standing atop a tall mountain on Earth. This pressure kept liquid water from boiling away, unlike modern Mars. The air was mostly carbon dioxide, trapping heat and keeping the planet warm. Without this greenhouse effect, Mars would have frozen much sooner. Winds swept across the plains, shaping dunes and carving rock. Dust devils spun across the surface, more powerful than today's. The sky might have glowed butterscotch or faint blue at sunrise. A spacesuit was still necessary, but the environment was less extreme. The thick atmosphere offered some protection from solar radiation. Losing this atmospheric blanket was a turning point in Mars's history. 1 billion years ago, Mars was likely a much wetter planet. Vast oceans may have covered the northern hemisphere, filling low basins. Imagine standing on a cliff, gazing at a Martian sea stretching to the horizon. Rivers flowed from the highlands, feeding these ancient oceans. We see evidence in river deltas, valley networks, and minerals that form only in water. These clues are fossils of a time when water shaped the land and climate. Oceans stabilized temperatures, moderating the climate. A water cycle, evaporation, clouds, rain, may have existed. Picture a rainy day on Mars, drops feeding streams and lakes. Where there's water, there's potential for life. Mars's wet past made it a prime candidate for life to emerge. Aquatic environments could have sheltered simple organisms. All the ingredients for life, water, atmosphere, energy, were present. Mars 1 billion years ago and Mars today are worlds apart. The transformation is so dramatic, it's almost hard to believe they're the same planet. Once, Mars was a world teeming with dynamic forces and the potential for life, but now it stands as a stark, frozen relic in our solar system. Ancient Mars had a thick atmosphere, flowing water, and active volcanoes. A world full of potential. Rivers carved valleys, lakes shimmered under a cloudy sky, and volcanoes shaped the landscape. The planet's surface was alive with geological activity, and the conditions may have even supported primitive life. Today, it's a frozen desert with a thin, almost airless sky. The landscape is silent, dominated by dust storms and extreme cold, with only traces of its vibrant past remaining. The turning point was the loss of Mars's magnetic field. This invisible shield once protected the planet from the harshness of space, but as it faded, Mars's fate was sealed. Without it, the solar wind stripped away the atmosphere, molecule by molecule. Over millions of years, the protective blanket that kept Mars warm and wet was blown into space, leaving the planet exposed and vulnerable. Air pressure dropped, water boiled away, and the greenhouse effect faded. The once thick air thinned to a whisper, and liquid water could no longer exist on the surface for long. Temperatures plummeted, water froze into ice caps and permafrost. Vast regions became locked in a deep freeze, and the planet's climate changed forever. Mars became a planetary fossil, preserved in the deep freeze of space. Its surface tells the story of a world that once had promise, now locked in silence and cold. Dry riverbeds and dormant volcanoes are silent reminders of a lost world. These features hint at the planet's dynamic past, when water and fire shaped its destiny. The northern basin hints at vanished oceans. Ancient shorelines and sediment deposits suggest that vast bodies of water once covered this region, supporting a very different environment. By studying these features, we read the story of a planet transformed by climate catastrophe. Each rock and valley is a clue, helping us piece together the dramatic changes that shaped Mars. Mars's fate is a cautionary tale of planetary evolution. It reminds us how fragile planetary environments can be, and how quickly they can change. Its surface is a record of profound change, a testament to the forces that can shape and erase entire worlds. If ancient Mars had water and a thick atmosphere, could it have hosted life? The conditions were promising, similar to early Earth, where life began in the oceans. If life started on Mars, it was likely simple single-celled organisms in water or soil. These microbes might have formed slimy mats on rocks using chemicals or sunlight for energy. Finding fossilized evidence of these mats is a key goal for Mars missions. Complex life, like plants or animals, was unlikely. Mars's habitable window closed too soon. The planet froze before life could evolve beyond microbes. We search for chemical signatures and microscopic fossils in ancient lakebeds. Even the simplest Martian life would be a discovery that changes our understanding of the cosmos. How do we know what Mars was like 1 billion years ago? We study today's Mars with robotic explorers, orbiters, landers, and rovers. Orbiters map the surface, revealing ancient river valleys and possible ocean basins. Spectrometers analyze rock composition, finding minerals formed in water. Rovers like Curiosity and Perseverance act as geologists, drilling rocks and searching for signs of past life. Curiosity found evidence of an ancient lake in Gale Crater. Perseverance is exploring a river delta, collecting rock samples for future return to Earth. These samples will be studied in labs, searching for clues about Mars's climate and life. Each mission brings us closer to understanding Mars's lost history. The Mars Sample Return mission could finally answer the question, was Mars ever alive? Long ago, Earth and Mars were planetary siblings, rocky worlds with thick atmospheres, water, and volcanoes, but their stories diverged. Mars, smaller and lighter, cooled quickly. Its core solidified, and its magnetic field vanished. Earth's larger size kept its core molten and its magnetic shield strong. This shield protects our atmosphere and allows life to thrive. Mars's weak gravity made it easy for gases to escape once the shield was gone. A single factor, planetary mass, led to two different destinies. Earth flourished. Mars faded. Studying Mars helps us understand what keeps Earth habitable. It's a natural laboratory for planetary science. Mars reminds us how fragile a habitable world can be. By learning from Mars, we better appreciate our own planet's balance. The tale of two planets is a lesson in cosmic chance. What does the future hold for Mars and humanity? Understanding ancient Mars helps us prepare for human exploration. Knowing where to find water ice could be key for future astronauts. Human explorers will be geologists and biologists, searching for evidence of past life. Some dream of terraforming Mars, rebuilding its atmosphere, and warming the planet. This would take centuries, but the idea inspires us to reach further. For now, every rover image and satellite scan is a step on our journey. Mars is more than a red dot. It's a destination, a museum of planetary history, and a mirror for our own aspirations. Our quest to understand Mars connects us to the universe and to our own future. The story of Mars is far from over, and we are part of its next chapter.